Welcome back to the Deep Dive. We're the place where we take apart some really complex tech stuff that's shaping our future and try to make it make sense for you. So we're right in the thick of this huge AI boom, right? Everyone's talking about it. But as smart as these machines seem, there's this fundamental issue. They can lie, like really convincingly. Today, we're plunging deep, really deep into the tech, aiming to fix exactly that. We're talking OriginTrail, that's TRAC if you're looking at tokens, and it's a pretty ambitious decentralized knowledge graph, the DKG.
That's right. And, this project isn't new. It's been around in the decentralized world since, 2013? Real veteran. But it's suddenly become incredibly relevant with this whole AI truth crisis blowing up. So our job today, cut through the jargon. You hear things like semantic fabric, ontologies, which honestly are just fancy ways of saying standardized systems for organizing digital facts. Think of it like a superpowered library catalog system. We want to explain how this thing actually creates a trustworthy, verifiable base for AI. And we'll keep it simple, focusing on why you should even care.
Okay, let's do it. Before we get into the weeds of the solution, the how, what's the actual problem? What real-world crisis, or crises, is OriginTrail trying to tackle right now? Seems like there are two big connected issues.
Yeah, exactly. Two main ones. The first is the one grabbing headlines, the AI hallucination crisis. Think about these large language models, the GPTs everyone uses. They learn from, the internet, which is a mess, right? But unstructured, chaotic. Their main goal is recognizing patterns and spitting out text that sounds good, that flows. Plausibility over accuracy, often. So what happens? They generate stuff that sounds totally right, completely confident, but it's just wrong, factually incorrect.
Magnificent BS artists, basically.
Precisely. That's a good way to put it. They're brilliant mimics, but terrible librarians when it comes to truth. And if you start depending on them for important things, medicine, finance, supply chains, whatever, that trust breaks down really fast. Then there's a second problem, which is just as big. The data itself. The information about real-world assets, or RWAs.
RWAs, so like physical stuff, shipments, products, research data.
Exactly. Yeah. Anything real. That data is all fragmented. It's locked up in what people call corporate silos, separate databases, different companies, different systems. So even if the data is accurate somewhere, the fact that you can't easily share it or check where it came from or prove it hasn't been messed with, it makes it pretty useless for an AI that needs reliable info. OriginTrail is hitting both things, the AI lying problem and this data access and verification problem, all at once.
Okay, so you've got AIs that sometimes lie, built on data you can't easily trust or access. How do you fix that? The team has this pretty striking vision, right? They say, what Bitcoin did for money, OriginTrail does for knowledge. That's a huge statement.
It is a massive claim, yeah. And the core tech trying to back that up is this Decentralized Knowledge Graph, the DKG. Here's maybe a simpler way to think about it. You know how Google uses its own internal private knowledge graph to connect facts and give you those info boxes?
Right.
Okay, so the DKG is like the Web3 version of that. But instead of being owned by one company, it's global, it's open, anyone can participate, and this is key, it's cryptographically verifiable.
All right, hold on. My skeptical brain kicks in here. If this DKG is the ultimate truth layer, why do huge companies need it to be decentralized and public? Wouldn't they just build their own private, secure graph? Seems, safer for them.
That's a really common question, and it hits the core difference. See, if you build a private graph, you only guarantee truth inside your own little world. But think about real-world stuff. Supply chains, clinical trials, global audits, these involve dozens, sometimes hundreds of different companies and organizations that need to trust each other's data.
Okay, so it's about trust between organizations, not just within one.
Precisely. The DKG isn't just about storing information. It's about guaranteeing the provenance, the origin story of that data, using cryptography, like a digital fingerprint trail. So even if a human still enters the initial data, the facts about a shipment, say the DKG uses crypto to make sure nobody tampered with it after it was recorded and verified by whoever submitted it. It creates this undeniable audit trail for facts. That's what allows it to be this foundational trust layer for AI. It's aiming to build what people are calling a verifiable internet.
Okay, the DKG is the trust layer, the verifiable foundation. Let's peek under the hood then. How does it actually do the fact-checking? How does it stop the AI from, making stuff up? This sounds like where the magic happens.
It is pretty cool, yeah. They use this unique approach called neurosymbolic AI.
Wow.
You can kind of picture it like pairing two different kinds of minds together. One is super creative, quick, maybe a bit wild. That's the neural AI. The other is like a meticulous, incredibly boring, but always accurate librarian. That's the symbolic AI.
Okay, creative but unreliable student meets boring but accurate librarian. Got it.
Exactly. So let's break down those two parts. One, neural AI. That's your LLM, your GPT, the creative one. Great with language, context, sounding human, but prone to those hallucinations we talked about. Two, symbolic AI. That's the DKG itself. It's all structured facts, logic, relationships between things. It's accurate, verifiable, logical, but zero creativity. It just knows the facts.
So how do they work together? There's this term DRAG, Decentralized Retrieval Augmented Generation. The D is for decentralized, right?
Yeah.
Meaning it pulls from the global graph, not one company server.
Spot on. And that DRAG process is the key mechanism. Here's how it works, simplified. An AI agent, maybe a corporate chatbot inside Microsoft's system, gets a question, a tough one maybe. Instead of just trying to guess or be creative right away, it first queries the DKG. It retrieves the actual proven, verified facts related to the question, and importantly, gets their origin where they came from.
Ah, so it grabs the evidence first.
Exactly. Only then does the LLM, the creative part, use those specific pre-verified facts to generate the answer. The answer is still fluent and human-like, but it's grounded in truth pulled from the DKG.
It's like forcing the creative student to use the librarian's verified notes before writing their essay.
That's a perfect analogy. And the fundamental piece of information in this whole system is something called a knowledge asset, or KA. Every verifiable fact, every piece of data put onto the DKG gets structured as a KA. Think of them as digital containers holding specific knowledge, usually linked to a real-world asset. And here's another layer. They're represented as NFTs.
Okay, wait. NFTs, non-fungible tokens.
Yeah.
Why? That sounds complicated. Does everything need to be an NFT now?
Fair question. But it's actually vital here for that verifiability aspect. Making the KA an NFT gives it a unique, unchangeable, cryptographically secure identity, like a digital passport for that piece of knowledge, tied to a specific thing in the real world. So imagine a box of medicine being scanned at different points in the supply chain. Each scan could generate data that becomes part of a KA, represented as an NFT. That NFT status guarantees that the package of data facts about the medicine's origin, temperature logs, location can't be secretly altered. Changing anything would break the crypto signature.
I see. So the NFT isn't about selling digital art here. It's about creating a tamper-proof digital twin or record for the data itself.
Precisely. It creates that permanent, unalterable record needed to feed reliable truth to AI. And the scale isn't trivial. We're talking, what, over 1.7 billion KAs already created as of late 2025? It's significant.
Wow, okay, 1.7 billion, so this isn't just a concept.
Not at all. And that leads right into the crucial next point. This is actually being used, like right now. We're seeing massive B2B adoption, business to business, which proves the tech isn't just theoretical. It works in really complex, high-stakes industries. Take logistics and audits. The DKG is being used by SCAN. That's the Supplier Compliance Audit Network.
Is SCAN? Never heard of them.
You might not have, but they're huge behind the scenes. They handle the verification for roughly 40%, 0% of all imports coming into the United States.
Wait, seriously, 40%? Who uses them?
The giants.
Yeah.
Walmart, Costco, Home Depot, tons of major retailers are members. They use the DKG to securely share and verify factory safety audits from their suppliers around the world.
Okay, 40% of U.S. imports. That's staggering.
Yeah.
But why the DKG? Why can't Walmart just get an audit report emailed to them? Or use some private database?
Because the risk of bad data is enormous for them. Think about it. If Walmart gets a safety audit report for a factory, they need to trust it's accurate and hasn't been faked or altered by the supplier or even the auditor. If they rely on a potentially dodgy report and something goes wrong, a safety issue, a regulatory breach, the fallout for Walmart is massive.
Yeah.
Reputational damage, fines.
Huge liability.
Exactly. By putting the verified audit data onto the DKG as a knowledge asset, Walmart, the supplier, the auditor, everyone involved has cryptographic proof that the data is authentic and hasn't been touched since it was created. It's verifiable by all parties.
Okay, that makes total sense now. They're essentially buying certainty, reducing risk across these complicated global networks.
Yes, precisely. They're buying verifiable trust. And we see similar things with Swiss Federal Railways, SBB, using it for tracking asset quality, or Aid Trust using it for transparency in distributing humanitarian medicines.
And then there's the big AI catalyst, the stuff that happened more recently, Q3, Q4 2025, especially the integration with Microsoft Copilot Studio. That sounds huge for getting this into businesses.
Oh, it's massive. Absolutely huge.
Right.
Because Copilot Studio is Microsoft's platform for businesses to build and customize their own AI assistants. And it's used by, get this, over 230,000 organizations globally.
Wow.
So this integration allows those 230,000 organizations to essentially plug the OriginTrail DKG in as verifiable memory for their internal AI agents.
Verifiable memory, like the fact-checking library we talked about.
Exactly. And the kicker is they can do it without writing a single line of code. It's designed to be easy for corporate users to just connect it. Suddenly, accessing globally verified data becomes potentially ubiquitous for enterprise AI.
That's a game changer for distribution.
Totally. And it's not just business data. We're also seeing moves into science, what's called DESI, or decentralized science. They partnered with Oxford Pharmagenesis, a big medical communications agency,
Oxford. Okay, what for?
to build a verified AI-ready knowledge base specifically for medical information. Because, the need for accuracy is just as critical, if not more so, when you're dealing with clinical trial results or drug information as it is for tracking shoes.
Makes sense. Verifiable truth matters everywhere. Okay, this sounds incredibly powerful, huge adoption, but nothing's perfect. This level of complexity, this ambition, it must come with risks, right? What are the potential downsides or criticisms our sources point to?
Absolutely, there are risks. The first one is kind of related to what we tried to avoid at the start, the sheer complexity, sometimes called the curse of complexity. While the core idea, neurosymbolic AI, is elegant, the technology underneath it, all the knowledge graphs, the ontologies, semantic web standards, it's very academic. It's dense stuff.
Right. Not exactly easy for the average person or even the average developer to just jump into.
Exactly. That creates a high barrier to entry. It makes it harder to market clearly, and it can slow down grassroots adoption by developers wanting to build new apps quickly on top of the DKD.
Okay, complexity is one hurdle. What else?
The other major one, and this is probably the most serious criticism from an economic perspective, is what we can call the core economic conflict. It's about the token, TRAC, and the business model.
Ah, the tokenomics. Let's unpack that conflict. So TRC uses a real yield model, right? Explain what that means for people holding or staking the token, and then lay out the tension.
Okay, real yield is important. It means the rewards paid out to the people who stake their TRD's tokens, the ones essentially running the network nodes, securing the DKG, those rewards come only from the fees paid by actual users publishing data.
So no printing new tokens out of thin air to pay stakers. The yield comes from real usage.
Correct. It's not subsidized by inflation. That's generally seen as a much more sustainable model long term, but it means the network needs significant usage, significant fee generation to be attractive for stakers. Now, here's the tension. To get those massive corporate clients on board, the Walmarts, the Microsofts, the Scan Network members, OriginTrail needs to offer really, really low and predictable costs for publishing data, for creating those knowledge assets.
Yeah, I see. The big companies want high-volume billions of transactions, potentially, but they need the cost per transaction to be tiny and stable.
Exactly. They need predictability. They can't have their operating costs suddenly spike because a crypto token price went up.
So the conflict is, corporate adoption requires driving the cost per knowledge asset down towards zero, but the token stakers rely on those fees for their yield. If the number of KAs explodes, which is good for corporate adoption, but the TRAC cost per KA drops too low, the total network revenue, the actual yield paid to stakers, could flatline or even drop.
That's the core dilemma right there.
Yeah.
You could theoretically have a situation where the DKG is wildly successful in the corporate world, used by everyone, processing billions of assets.
But if the fees per asset are minuscule, the TRAC token itself might not capture much of that economic value for its holders or stakers. Corporate success doesn't automatically equal token success.
Precisely. It's a very delicate balancing act for the protocol. They have to satisfy the enterprise customers who need low, stable costs, and the TRAC stakers who need a competitive return on their investment, driven by those usage fees. Managing that balance successfully is, frankly, the ultimate financial test for the project.
That's a critical point for anyone looking at this. What about regulatory risk? Is that a hurdle? Crypto regulation is always a minefield.
Actually, on the regulatory front, they seem quite well positioned, especially in Europe, which is often ahead on this. The TRAC token got a favorable classification under the EU's Big Crypto Framework, MiCA. It was classified as an other crypto asset, which crucially excludes it from being treated as a security in the EU.
That's huge for institutional comfort, right? Removes a major roadblock.
It's a very big deal, yeah. Provides a lot of clarity for businesses wanting to use the system or even hold the token. And things in the U.S. seem to be trending more positively, too, with potential legislation like the Clarity Act aiming to provide similar frameworks. So regulatory risk seems lower here than for many other projects.
Okay, good to know. So let's try and wrap this all up. If you had to summarize OriginTrail in just a sentence or two, it's essentially a decentralized knowledge graph, the DKG, acting as a crucial trust layer for AI. It uses this neurosymbolic approach combining factual AI with creative AI to feed verifiable crypto-secured facts to large language models, stopping them from hallucinating. And importantly, it's not just theory. It's backed by some really significant real-world corporate use cases like SPAN and the Microsoft integration.
That sums it up nicely. The tech works, it's live, it's being used by major players. The problem it solves, this crisis of truth in AI, is massive and undeniable. So the final thought, the big question left hanging, is purely economic. Can the inevitable exponential demand from businesses and AI for verifiable truth generate enough total economic value flowing through the network fees? Can that value creation, driven by demand for truth, outpace the network's need to keep the cost per truth low enough for mass adoption? That's the billion-dollar question the market needs to figure out.
A fascinating economic test ahead. All right, that brings us to the end of this deep dive. If you found this interesting, please like and subscribe to the channel. We do all the complex research so you don't have to. Thanks so much for joining us today. We'll catch you on the next one.